The probability of picking a blue marble from a bag is 4/7. Find the odds of part A, selecting the blue marble. So since we want in favor of picking a blue marble, we'll use that first line there. What's the probability of picking a blue marble? 4/7. Remember, probability fraction, the numerator's got to be less than or equal to the denominator, so it can't be 4/3. Oh, who said 4/3? Oh, you went ahead. Okay, then it blended together in my ears. All right. That's in purple. 4/7. 2. So that's the probability of picking a blue marble. 2. What's the probability of not picking a blue marble? 3/7. We're not done. We need to reduce this now. Now, when I said that A and B from earlier, though, that A and B are whole numbers. So we can't have fractions here. In this case, we need to multiply something to make those into whole numbers. What would we multiply by? 7 to clear out those fractions. So if we multiplied both by 7, what would you say? 4/3. Sure, if the probability of picking a blue marble is 4/7, then probability of not, we would subtract that from 1. So 1 minus 4/7. Is that okay? So in other words, assuming there's 7 marbles in the bag, 4 of which are blue, 3 of which are not blue. So that's another way of thinking about the A and the B. Is that okay? So assuming there's 7 marbles in the bag, 4 are blue, 3 are not blue. Well, you have to be careful if, does it agree with the lettering, the wording? So since it's the probability of picking blue, and part A is we want to pick blue, then yes, the numerator would come first. But in B, it says not picking blue. Well, if the odds for picking blue are 4/3, then the odds against picking blue are 3/4. So just be careful with reading it. So again, the probability of picking blue is 4/7. The odds of picking blue are 4/3. Well, it's 2 different ways of saying the same thing. So just be careful. So notice when you write odds, you don't write the total. Are 4/3. So out of the 7 total, 4 and the 3, 4 are blue, 3 are not. You don't write the total. When you write a probability, you write the total, the 4/7. Assuming there's 7 marbles in the bag. So let's go the other way. A box of Forrest Gump chocolates contains 12 milk chocolates, 10 dark chocolates, 8 caramel or caramel, your choice, chocolates, and 4 icky coconut chocolates. Who likes coconuts? No, they're icky. Icky, yes. Part A, find the odds of selecting a milk chocolate. Now, this is where we would use this information, number ofs. We don't need to write them as probabilities first. So the way I want you to interpret A would be, how many are milk chocolate? 12. Hold on. Why isn't there a brown? Brown would make sense here. We'll go orange. 12. 2. How many are not milk chocolate? 22, because we got 10 plus 8 plus 4. So 12 are milk chocolate, 22 are not milk chocolate. Is that okay? We're not done, but is that okay so far? All right, now we got to reduce it. 12 and 22, what number can we divide by to reduce it? 2, and if we divide by 2, what do we get? Yeah. It's okay. No one's got to know. Good. So the odds of selecting milk chocolate, 6 to 11.
So if we wrote that as a fraction, it would be wrong.
Correct, because the directions are odds. But part B, find the probability of selecting your milk chocolate. Remember, probability is part over whole. So you can use part A if you want, and using these formulas here, or you can just go back to the original problem. So the numerator will represent the number of milk chocolate pieces, which would be 12, over the denominator represent the total number of pieces, which would be 34. And how does that reduce? And that should make sense from part A, because out of the 17 total, 6 plus 11, 6 of which are milk chocolate. And that's what these formulas say. Okay. C is just like A. Find the odds of selecting caramel or dark chocolate. We're assuming that the caramel one is not the same as the dark chocolate one, otherwise I'd have to give that information. So in other words, they're mutually exclusive. So how many caramels are there? 8. And how many dark chocolates are there? So how many caramels or dark chocolates are there? 18. 2. How many are not caramel or dark chocolate? 16. Is everyone okay so far? Reduce it like you've never reduced before. 9 to 8. Does anyone want chocolate now? Yeah. See, the correct flavor would have been chocolate and peanut butter. That is the best thing ever. Yeah. In fact, I've already decided that my casket will be chocolate and filled with peanut butter. And I'll be in there. What? What better way is there, really? D, the probability of selecting caramel or dark chocolate. How many total caramel or dark chocolate pieces are there? 18 over how many total pieces are there? 34. Good, and how does this reduce? Good. E, what are the odds of not selecting a coconut chocolate piece? Well, the number that goes first are the numbers that are not coconuts. How many are not coconuts? 30, the 12, the 10, and the 8. Is that okay? So 30 are not, excuse me, I'm getting verklempt. 2, how many are coconuts? 4. So again, the number they're asking for is the number that goes first in an odd problem. How does that reduce? 15 to 2. Hooray!